In 10.4, we explore logarithms a little bit deeper. Turns out there are some really useful properties of logarithms, um, right? So the flip side to logarithms are exponentials, right? It turns out they're inverses, and we're really going to see that. We see it more so in this section, and then we really see it in action in 10.5 when we start solving equations. But the reason I bring that up now, there are lots of properties, or sometimes we call them the rules of exponents. Well, just like all the rules of exponents, there are rules for logarithms, or you might say properties for logarithms. Turns out there are six, and so we're going to look at those right now, and then we're going to simplify things, that sort of thing. That's the nature of this section. I believe there were actually six rules for exponents too. So it's like all the equivalent rules. Okay, so as we're going through these rules, I'm going to give you just a quick explanation for some of them. Some of them, not really, just maybe a vague idea of why they're true, but that's all based on this: the fact that y equals the log of x with base b can be interchanged or is equivalent to x equals b to the y. All right, so here is the first property. The log of 1 with any base is always equal to 0. If you're ever taking the log of 1, it does not matter what your base is, you always get 0. Why is that? Well, there's a similar rule of exponents. Anytime you raise something to the 0 power, you get 1. Now, why would that be? Well, think of 1 equals b to the 0 as this. X is 1, y is 0. Well, if you rewrite it, x is 1, y is 0, you get that. It's actually the exact same rule, just in the logarithmic form. So here's our rule. The log of 1 with any base equals 0. Keep that in mind. Okay, rule number 2. This is kind of an interesting one. The log of b to the x with base b equals x. The log of b to the x with base b equals x. Why is that? Well, this one, the reasoning, it's like it's so simple it can be confusing. So think about that equivalence, and we're going to end up with this very simple true statement. So this looks like y equals the log of x with base b, right? So that's our x, that's the y. So if we rewrite it, then this x equals b to the y. I'll say it again. So here's like the x. So x equals b raised to that. And well, I think we would all agree this is true. And so rewriting it in the logarithmic form, we get this. And it's like this, okay, that's strange. So the point is, if you ever see the log of a base raised to something and that base repeats here, then the log with that base and the exponential with that base cancel out, and we just get whatever that exponent was. Okay, obviously we'll do examples with numbers, and maybe it'll be a bit easier to see it in action that way. If you like that last rule, here's this one. It kind of takes a similar thing. Think of this base b raised, so this is the exponent. This b is being raised to the log of x with base b. The logarithm is put into the exponent, and that equals x also. Now that's really weird, but what's the reasoning? Okay. Think of this. I'm writing it a second time here because it's strange. All right. So think of I'm just switching the sides here. Thinking of it as x equals b raised to the log of x with base b. Think of that as this form. X equals b to the y. Just that y equals that whole thing right there. So then if I rewrite it, if I take it and put it in this form, So there's y, so it comes over here. It equals the log of x with base b. Like, what just happened there? Like that, it's, I just get this true statement, right? So I think we'd all agree that's true. And so if I then go back and I rewrite it in the exponential form, I end up with my property. Okay, so what I want you to take away from this is that, again, exponentials and logs cancel each other out. So if I see base b there, and it's raised in its exponent is a log with base b, those cancel out, and we just get whatever that is. It simplifies. Okay. Those are the first three properties. Here are 4, 5, and 6. 4, 5, and 6, especially 4 and 5, have a very close similarity. Okay, so let's look at number 4. Now this is strange. The log of x with base b plus the log of y with base b. If you're adding two logs and they have the same base, you can combine them to a single logarithm with base b, and then we multiply the two arguments. So the new argument is the product of the old arguments. You're like, what is that? What a strange rule. If I add two logs, it's actually just one log, and I multiply the two arguments? Weird. Okay, let me show you the equivalent rule of exponents. So this isn't really a full-blown explanation, but I think it'll make the point. There's a connection between adding and multiplying. Okay, so the rule of exponents was a to the m times a to the n. So I'm multiplying, but how do I simplify that? I add the exponents, right? So there's this connection between multiplying and adding. And this is the way it works with exponents. But with logarithms, it looks like this. So if I'm adding the logs, then I multiply there. It's kind of, no, it's a strange rule, but I think most people kind of get multiplying and adding. There's a connection there. Okay, what if instead, property number 5, we subtract? So I've got the log of x with base b minus the log of y with base b. Now usually after people see that property number 4, property number 5 is like, oh, okay, I know what to do. If adding means multiply, then subtracting means divide. So these two logs become a single log base b, but now I divide the arguments. I take the first one divided by the second. So whatever was being subtracted, that's what I divide by, x divided by y. And that becomes just a single new argument. Okay, if you want to see the equivalent rule of exponents, there was a situation where dividing and subtracting went together, right? A to the m divided by a to the n. We can put that together with m minus n, like that. So subtracting and dividing have a connection. Okay, the last rule of exponents is this. That's an r. We don't see the variable r a whole lot. R multiplied by the log of x with base b. So it turns out, who would ever think this? This is just totally out of the blue. It turns out I can take that r and I can move it up into the power of x. This is the same as the log of x raised to the r with base b. Super weird. Okay, so what's the equivalent rule of exponents? Well, there's a connection between multiplying and raising to a power. A raised to the m raised to the n, in this case we multiply. So multiplying and raising to a power have a connection. A power to a power even, right? So raising to a power and multiplying. Anyway, it doesn't really matter if you know where the rules come from. Maybe seeing that connection helps them to kind of stick in your memory. But at the end of the day, we just need to know these 6 properties. So let's look at examples. I'm going to summarize these just in one short list, and then we're going to look at some examples in the next video.